Hello world, welcome to the Introduction to Right Triangles review. So if you're watching this video, you've probably been studying right triangles as it indicates right there. So if we flip down to the next slide. So what we're going to be exploring here would be using the Pythagorean theorem, good old a squared plus b squared equals c squared, using the converse of the Pythagorean theorem for classifying triangles based on angles, and special right triangles, the 30, 60, 90, and the 45, 45, 90 triangles. Okay, so let's get going. We got some practice problems coming up. Practice problems. All right, so these are just your traditional Pythagorean theorem problems. They don't specify if they want you to leave things as a reduced radical or as a decimal. So we'll do both. All right. So one thing that they do ask us to do here is not only find x, but to determine if the side lengths form what's called a Pythagorean triple. That's when all of the sides of your right triangle are whole numbers. Okay, so Pythagorean theorem, as you've probably studied, would be a squared plus b squared equals c squared. C is the hypotenuse, and it's also known as the longest side. Okay, so one thing I suggest that students do is maybe put a ring around the hypotenuse whenever you see a right triangle that needs solving. So in this case, we'd be solving for the hypotenuse. Let's take our little Pythagorean theorem and put it over here. By the way, I pointed out that the c side that's squared, that's the hypotenuse. Of course, we know those are your legs. Okay. So when you set this up, you have leg squared plus other leg squared equals hypotenuse squared. 49 plus 121 equals x squared. And that's going to be 170 equals x squared, I think. Yeah. So in order to get x by itself, we must take the square root of both sides, and we end up with x equals the square root of 170. So if we tried to reduce that radical, you'd end up with, I'm going to make a little factor tree under here, 17 times 10, 17's prime, and then 10 is just 2 and 5. So 2 times 5 times 17, there's no perfect squares there, so we really don't have to worry about that. If we want to know what the square root of 170 is, we can just punch it into some kind of a calculator. So square root 170, and that's going to be about 13.04. 3.04. Okay. Next one. So in this case, the hypotenuse, we know we're trying to find one of our legs. So this is, a leg. So we have x squared plus 7 squared equals 9 squared. X squared plus 49 equals 81, and minus 49, minus 49. I'm not taking chances, kids. All right, so this is 81 minus 49, 32. Take the square root of both sides. X equals, ordinarily, I didn't mention this over here, but when you take the square root, it's plus or minus, but in this context, we want to just deal with positive sides. So we have the square root of 32. Now that, you could think like, what's the biggest perfect square that divides evenly into this number? And that would be 16. So you could rewrite this as the square root of 16 times the square root of 2, which is 4 times the square root of 2. That's the reduced radical version of this. If you were to go over here and see the square root of 32 is going to be 5.7. You could say x is about equal to 5.7. Either way, Both of those answers are acceptable. You decide, depending on the directions, you decide what to use. For those of you who are curious, 4 times the square root of 2 is another version. It's another way to write the square root of 32. If we were to take that answer and go 4 square root of 2 and punch that into a calculator, you still get 5.7. Same exact answer, same exact value. It's just a different way of writing it. All right, moving on. Now another application of the Pythagorean theorem is if you flip it around and you're given all the sides of your triangle, you could determine if it's a right triangle. First of all, if the Pythagorean theorem works, it's definitely a right triangle. If it doesn't work, then you could just stop and say it's not a right triangle, or we have a couple scenarios. Now, before we even decide, okay, is it a right triangle, acute, or obtuse, and we discuss that rule, let's actually just talk about if the triangle actually forms, the 3 sides actually form a triangle. That's something that whenever you see these kinds of exercises, it's possible that somebody will throw you a curveball. Now, in order for a triangle to exist based on 3 sides, there's something called the triangle inequality. So maybe we just will note that here. The triangle N-E-Q-U-A-L-I-T-Y. And what that says is A plus B must be greater than C. And notice they're not squared. This is very different from what we're about to do. This is not Pythagorean. It just basically says in English the sum of the 2 smallest sides must be strictly greater than the 3rd side. Okay, so it's funny that I wrote that down for you because I could just say it, and it's fun that you can just look at me writing that. I will provide these notes someplace. All right. So that's a quick test. So you just look at the 2 smallest sides, you add them, and see if they're greater than the 3rd. So we can look around here. Let's just actually find those right now because I don't feel like worrying about that as I do this exercise. So which ones aren't even a triangle? They just can't make a triangle. 10 plus 11 is greater than 14. Yes. 6 plus 8 is greater than 10. 16 and 12 greater than 20. 15 and 20 definitely greater than 26. So we're doing pretty well so far. For number 5, yeah, I mean, even if we round it down, 5 plus 6 is greater than 7. So 6 is the last one that could even be a problem. So we have 10 plus, I don't know what the smallest side is here actually. So 5 times the square root of 13, we could try to estimate what the square root of 13 is. It's definitely less than 4, but greater than 3. So even if we made it 3, if we made the square root of 13, just call it 3 roughly, that would be 15. And the biggest it would possibly be would be 4, which is not because that'd be the square root of 16. So 5 times 4 is 20. These two exceed 20. So we're in business. We're fine. So none of these are not triangles. Okay. An example of something that wouldn't be a triangle is if you had something like 2, 3, 7. You'd be like, okay, 2 plus 3 is 5, and that's not greater than 7. Some of you may be wondering, why is that? Well, if this is 7, right, then this is 2, and this is 3. They're not long enough, even if these were rotating around, this is like their range of motion. They can't reach each other. They can't make a triangle. They're not long enough to extend beyond the longest side so that they can meet. So that's the idea behind the triangle inequality. But okay, now that we know they're all actually triangles, we need to determine, are these triangles acute, right, obtuse, one or the other. There has to be one of those if you have a triangle. So those are angle classifications. We know that most of these are scalene. even if they're equilateral or isosceles, doesn't matter, those are side classifications, you can still determine whether you have acute, right, or obtuse. So the rules on that, I'm going to write that right over here real quickly, would be take the longest side, C, you square it, and then I like to put a little box, okay, and then I'm going to say, I'm going to compare that to a squared plus b squared. Now, if I'm going to write that down 3 times. If you do this exercise, the one thing that you need to know is that this side is the longest given side. Notice I'm not saying hypotenuse because a hypotenuse is exclusive to the right triangle. This is just your longest given side, and then the remaining sides that are being summed are your legs, or the small, sorry, they would be in a right triangle, your legs, but that would be your just the remaining sides. If we have equals, that means right triangle. If the longest side squared is greater than the sum of the squares of the other side, then you have obtuse. Okay, and then I guess you could assume if c squared is less, that's going to be acute. Again, this is a review. Some of you are kind of like, all right, I already know this, but I make sure. So we'll just keep that handy. We'll just kind of throw that up here. So you have your the 2 concepts that we just reviewed, just kind of chilling out. All right. Fine. All right, here we go. So let's put a ring around the longest side and then go. All right, so it's going to be 14 squared blank 10 squared plus 11 squared. So we're going to find out 14 squared, that's just going to be 196. And then 10 squared plus 11 squared, that's 100 plus 121, that's going to be 221. Now we know that this is less than, meaning our answer is going to be acute. Okay, I didn't do this earlier, but as with most online videos, you see the problems here. You might want to pause the video and try them on your own, and then you can speed through and see how you did. All right, so hit pause now. Welcome back. All right, so this one's actually a Pythagorean triple. It's 6, 8, 10. So we know it's a right triangle, but just for giggles, let's watch it happen. So it's going to be 10 squared and blank 6 squared plus 8 squared. This is 100. Is 36 plus 64 100 equals. So that means we have a right triangle. Moving on. 20 squared blank. I switched to blue, sorry. It's okay though. I'm sure you enjoy the variety. So this is 400, and then I'm going to go over to my little calculator here and just say 12 squared, whoops, 12 squared plus 16 squared. That's also 400. Look at that. All right, also a right triangle. Yay. This one's a little bit interesting. I mean, I'll wait for the decimal one. All right, 26 squared blank and 15 squared plus 20 squared. 26 squared, 676. 15 and 20, I have a feeling they're not equal. 15 squared plus 20 squared. That one you could probably just do near, what's that, 400 plus 225? Yeah. All right, 625, and then that's greater than, which we all know is obtuse. Moving on. All right, so 7.8 squared blank 5.3. 3 squared plus 6.7 squared. Definitely need a calculator for this one. 7.8, 60.84. 5.3, 6.7. All right, 72.98. That's less than, so we know we're dealing with acute. Almost there, kids. So this one's 5 root 3. We talked about that one before. We know it's somewhere between 20 and 15. So it's definitely going to be bigger. It's going to be the biggest side. So 5 root 13 blank, sorry, squared, blank 10 squared plus 15 squared. So 5 times the square root of 13 squared. Then when we have that whole quantity squared, you're going to square both. This becomes, if I were to scribble that out, squared and squared. That's when you're actually multiplying two numbers together and you square the full quantity, you apply the square to both. And you can think about that on your own. So what we have here is 25, and then when you square a square root, that's just times 13. I don't know that off the top of my head, so I'm just going to go 25 times 13, and it's 325, right? Blank, and that's 100 plus 15 squared is, I think, 225, but I'll just be, now I'm thinking back, did I miss one of these other ones up? Did I say that, yeah, that's right, 225 and 15 squared. Okay. Just to lead you kids astray. Right, am I doing this proper? Probably, yeah, so it's 100 plus there's 325. 325, oh yay, they're equal. All right, cool. Moving on. All right, so that's pretty much your right triangles, you know, just your starter set with dealing with the Pythagorean theorem, how you could work forward and just find missing sides using the Pythagorean theorem only exclusively on right triangles. And then when you work in the opposite direction, if you have all the sides, you can determine acute, right, or obtuse just based on size, which is kind of a cool thing. Anyway, moving on. So here's an application of using the Pythagorean theorem to, say, find an area. So when you look at this, they tell us in the description, also we can just see from the picture that it's an isosceles triangle, and we know that if we need to find an area for a triangle, area equals 1/2 base times height. So the base is equal to 12. The height we don't know. But when you drop an altitude like this, right, you're like, all right, there's my altitude, and you want to figure out the height. One thing that you'd remember from isosceles triangles, when you drop an altitude from the vertex angle, it actually becomes a perpendicular bisector. So you could actually just rewrite this as 6, and this is also 6 over here. So you could focus on just either one of these triangles. So we have, this is a leg, h is a leg, 6 is a leg, and now 10 is our hypotenuse. I'm going to put a ring around there, that's fine. And you go h squared plus 6 squared equals 10 squared. Some of you may recognize the 6, 8, 10 again. This is h squared plus 36 equals 100. H squared equals 64 when you subtract 36 from both sides. And then h, when I take the square root of both sides, is equal to 8. So now h is equal to 8. A equals 1/2 12 times 8. 6 times 8. A equals 48 centimeters squared, or square centimeters. Okay. Fun application. Sorry I didn't tell you to pause the video. Hopefully you did. All right, moving on. Oh, look at that. Duplicated problem. We'll skip that slide. All right, now, They say find the value of the variable, and all they give me is a 45-degree angle. So we're going to need to take a look at this. Hold on, just grabbing a sip of water here. So they only give us one of the sides, and we need to find the one missing side. Now this is a 45, 45, 90 triangle. As we discussed in the intro to this video, this is the other big topic, special right triangles. As a refresher, the reason we have these 45, 45, 90 and 30, 60, 90 triangles, these shortcuts that are established, these relationships, is because all 45, 45, 90 triangles are similar because of angle-angle, the similarity postulate. So 45, 45, 90 is an isosceles right triangle. So if I label this 45, the reason they're only asking us for one thing here is because this side is also 14. Sometimes they don't tell us that it's a 45, 45, 90. They only tell us that it's a isosceles right, and then you figure that out. So there's one relationship that you really need to know here. So for the 45, 45, 90, and I will just write this down for you, 45 degrees by 45 degrees, 90. Oh, that's the weirdest right angle symbol ever. Okay. So this is a leg. So about the same. And this is going to be our hypotenuse, but this is leg times the square root of 2. So but we also know this as the short for hypotenuse. Okay. So I like to just write down hyp equals, you know what, let's just be consistent here. I'll say hyp and then equals leg square root of 2. I don't know, I'm just using different colors just to try to make it somewhat more interesting. And then I use that lame box that I just threw around there. All right. So that's the relationship. I mean, you could rewrite it as leg equals hyp divided by root 2 if you like, and then you'd have to rationalize that, blah, blah, blah. Okay, so I'll just leave that, just kind of let it hang around on this slide here. All right. So now we need to find x. So since the hypotenuse, in this case, I'll put a ring around it, that's our hypotenuse, is x, we know that x is going to equal 14 times the square root of 2. Done. So that's really nice. So when you know the leg, hypotenuse is a piece of cake because you just throw a radical 2 or a root 2 on the side and you're done. They get more complicated. They'll give you decimals, or they'll give you some radicals and whatnot. So they kind of push your recall of the rules of algebra, like in this case over here. So we're gonna end up covering a couple things. So again, we know that hyp equals leg times the square root of 2. Okay. So again, let's identify the hypotenuse. So this time we actually know the hypotenuse. So there's a couple ways to go about this. When you're really good, you just kind of go for it and you know what to do. But let's just say you forget. You say, all right, well, I'm going to just plug into the relationship that I have here what I know and what I don't know. So I know the hyp, right? Hyp. All right. So I know hyp is equal to 45. And the leg is x. And that's being multiplied by the square root of 2. Well, I need to get x by itself. In order to do that, you divide both sides by the square root of 2. So now what do we have? We have x equals 45 divided by the square root of 2. You can't leave it like that. I mean, it's technically the right answer. If you plugged it into the calculator, you'd get the same thing that you'd get if you rationalized it. But we want to make this rationalized. Rationalized means you're dividing by an actual whole number, not an irrational number. So the safest way to do that, and the most appropriate way to do that, is to multiply the top and the bottom by whatever the radical expression is in the bottom. So because when I multiply that radical expression by itself, the radical goes away because you're squaring the radical. You're not allowed to square the top and bottom of this fraction. You're allowed to multiply top and bottom by the same thing. So then you end up with 45 square root of 2 over the square root of 2 times the square root of 2, which is simply 2. And that's your final answer. Most textbooks have you just leave it like that. If you want, we can also just express that as a decimal. I'd just like to show you how you would enter that into a calculator. It's just basically 45 and then times, you don't have to write the x here, but I'm just really emphasizing the fact that when it's next to the square root of 2, you're saying I have 45 square root of 2's, right? And you're like, all right, that's cool. And then I go divided by 2, which is 31.8. It's approximately equal to that. Okay. So that's your final answer for that. All right. Now, when you look at something like this, if you're really bringing your A game and you're familiar with this, it isn't as annoying and complicated as like, oh, I have to write down hype equals leg root 2 every time. You say, well, if I know the hypotenuse and I don't know the leg, ordinarily I would say hypotenuse equals leg root 2. Well, if I know the hypotenuse and not the leg, I go in reverse. So I just say the leg must equal 45 then divided by the square root of 2. So that makes sense, because if I were to go ahead and multiply this by root 2, like 45 over root 2 times root 2, that would get me my hypotenuse. So that's how you know it works. So you could just go do the inverse operation when you're trying to find the leg given the hypotenuse. You can then fly through these wicked fast. All right, moving on. This next scenario, the 30, 60, 90. It's classic. So let's not waste too much time on this. I know this video is getting long, as they do. Not drawn to scale, this triangle is. You know what I'm going to try, just for giggles? I'm going to cut this, I'm going to paste it, and then it's not going to let me resize it. Let's try to just resize. Nope. Yeah, it's going to keep it scaled proportionally. That's funny. Alright, well, you have to just trust me on this one. This is a 60-degree angle, and this one is 30. Across from the 30 in a 30, 60, 90 triangle, 30, 60, 90, these are degrees. Across from the 30 is going to be what you'd call the short leg. Okay, across from the 60 is, I call it LL. Use cursive L's because otherwise it looks like 11. That's your long leg, and the reason it's the long leg is it's the other leg. There's only two legs. That's across from the bigger angle. So across from the smallest angle in the entire triangle is going to be your shortest side, but it's also the short leg. Across from the 60 is the long leg, and then of course from the 90, we all know that's our height. So there's two relationships you need to know. Let's try that again. The height is going to equal simply 2 times whatever our short leg is. Okay? Just whatever your short leg is, you double it. So, cool. And then the long leg is going to equal whatever our short leg is times the square root of 3. So again, that first one was a fun mistake. Strike that from the record. Okay. So now, we have those relationships down. And I'm assuming that you're not learning this for the first time. Then we're going to go ahead and solve these. Okay. So in this case, they give us a short leg. And that means that this is 60. And that's LL. And this is height. You don't have to do this every time, obviously. And since we know the short leg, we know that x, our height, is going to equal double 2 times 9, x equals 18. You can even write that right on the diagram. And we know the long leg, y, is going to equal our short leg, 9 times the square root of 3. And that's it. So got that one, you got that one, equals 9 root 3. All right. Moving on. We're getting close here, kids. Next one, this is 30. Okay, so let's again identify height, short leg, long leg. Well, we know that the height's relationship to the short leg is height equals 2 SL, right? So the height is 24, and the short leg is y, so it's 2y. You can solve, divide both sides by 2. Y equals 12. Some of you are like, yo, like, if the height is double the short leg, y would have to be 12. And you just look at it, you'd figure that out right away. I know. I'm just taking it, taking it slow for the people who have their training wheels on. All right. And then the long leg is just going to be whatever the short leg is times root 3. So it's going to be 12 root 3. So x equals 12 times the square root of 3 because x is our long leg. Moving on. Sorry again, I haven't done these videos in a little while. Just remember at the beginning of all these problems, you should probably be pausing it and making sure you know what you're doing. This is our last example. So this is, I'm not going to say it's the hardest that it gets, but this is entering the realm of it being the hardest because when they give you the long leg, you have a little bit of radical dividing to do sometimes. So I'd say this is about as hard as it gets. So let's identify our sides again. Hype. This is our short leg. How do I know? Because it's across from 30. And this is our long leg. All right, so we know the relationship between short leg and long leg, given that we have the short leg here. That was a lame underlining. Okay, whatever that means. We have long leg equals short leg and then root 3. So let's plug in what we know. We know the short leg is y root 3, and the long leg is 6. So in order to get y by itself, we have to divide by root 3. So y equals 6 divided by root 3. And as you know, we have to rationalize, multiply top and bottom by root 3. So we end up with 6 root 3 over 3. And some of you are like, yo, you can reduce that fraction. And you are indeed correct. So this is going to equal 2 root 3. So y, our short leg, is equal to 2 root 3. Label it on the diagram, because once it's there, now you're like, oh, cool. If that's 2 root 3, like if I have 2 root 3's, then my hypotenuse is double that, so I have double the amount. I have 4 root 3. That means that x equals 4 root 3. My hypotenuse is double my short leg. And those are the answers, x and y. All right, I hope that video was helpful, and check out the slideshow in the description below. There should be a link to it somehow. Thanks for watching.